So I've given the toolkit here. We've given the toolkit and we've given our acceleration due to gravity, and I've shown it as its direction. I'm showing it as its vector. And then we've got a problem. Our problem is we're going to shoot an arrow up to the top and it's going to come down to the bottom. We've got our reference line here as y is equal to 0. And we know that my tower is 30 meters tall. And we're going to shoot the arrow up at 30 meters per second. We can represent this as a one-dimensional problem. So we're going to represent this as a one-dimensional problem, and we're going to work with that. So we want to know, how high does the arrow get above the ground? And very careful about how we've worded that question. How high does the arrow get above the ground? And how long does it take for the arrow to hit the ground? So that's our problem that we've got. We've got our castle. We're going to work on that, and we are going to work the problem here. So I'm going to come over here. We're going to do this. I'm going to share that. I'm going to move my screen. And I have my problem. So you can clearly see the problem here. I'm going to move it up so that I'm not reading the problem. Clearly see the problem that we have. The arrow is shot straight up from the top of a 30-meter tower with the initial velocity of 30 meters per second. We want to know, how high does the arrow get above the ground and how long does it take for the arrow to hit the ground? Typically, you're not given the picture. So first thing you want to do is draw your picture, and then you want to write down the information that the physics problem didn't tell you, but they assume that you know that you know. So we assume that everybody's going to remember that the acceleration due to gravity is 9.1 meters per second. And we have that going down. So one of the things we're also going to say is going down is negative. All right. So this height here, the height of our tower, h, is going to equal a minus 30 meters. Because my reference line here is 0. All right. So the height above the ground, the height that we're trying to find, is going to be this height. That's why I said pay attention to the way the equation works, because this is going to be the height above the ground. Now, there's also some other information that we know that it's not necessarily telling us as clearly as that. Because vectors have direction and magnitude. We know my initial velocity, because it told us that, is 30 meters per second, and it's going up. But when we get to this top point, this point right here, the velocity is changing direction. So the velocity at that top point is going from positive to negative. So velocity at the top is going to equal 0 meters per second. Because vectors have direction and magnitude. So that gives us something really special to deal with. So now if I look at what I know my initial velocity is a positive 30 meters per second. I have an acceleration that is a negative acceleration, that's negative 9.81 meters per second squared. I have a final velocity at the top of 0 meters per second, and I want to find a height. So I can find this distance from my initial point to up here. And one of the equations we can use is my final velocity squared is equal to my initial velocity squared plus 2 times my acceleration times my distance that I'm looking for. So I'm going to do final velocity squared minus initial velocity squared divided by 2 times my acceleration is equal to my distance. This is equal to 0 minus 30 meters per second squared divided by 2 times a negative 9.81 meters per second squared. I get meters squared divided by seconds squared. I'm going to cancel out 1 meter and I'm cancel out my square, and I'm going to end up in meters, which tells me I've done my algebra right. And when I plug that into the calculator, I ended up with 45.87 meters. But guess what? The question was asking me the height above the ground. So this is 45.87 meters, and this is 30 meters. So the height above the ground is going to be the addition of that. So it's going to end up being 75.87 meters. But now I got to find the time. There's a couple of ways we can do it. All right. I know that my change in position is going to be negative 30 meters. So I could use my change in position is equal to my initial velocity times time plus 1/2 acceleration times time squared. And then I have to use my quadratic equation. Or I can do my final velocity is equal to my initial velocity plus my acceleration times time. And that way I'm looking at the time of fall. But I still got to know that part. So I'm going to use this one. Because we have to think through how we're going to do that. So let's use this one. So we're going to look at that one. So I'm going to do my change in position is equal to my initial velocity times time plus 1/2 acceleration times time squared. This is going to be minus 30 is equal to 30 times time minus 9.81 divided by 2 times time squared. And then I can do my quadratic equation, or so I can do t is equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a. And if I do that with that equation, I ended up with time could be a negative 0.844 or a positive 6.991 seconds. And since time can't be negative, we're going to get the positive 6.99 seconds. I'm going to see if I can get everything onto the one screen here. You have an example in the textbook that's very, very similar to this. And in fact, that's the next thing I'm going to do here. Stop sharing. I'm going to stop recording.